60 years. Scientists asked, where did Venus's oceans go? Answer sparks 3 scarier questions. After evaporation, where are water molecules? After splitting, where's hydrogen? Third, hydrogen escaped. Why not Earth's then? Link 3 answers. You'll find chilling truth. Earth and Venus differ far less than we think. If conditions shift, Earth may follow Venus. First, Venus ocean. Before 1962, people imagined Venus hospitable, near Earth, similar size, thick cloud. Mariner 2 flew by and found 400 degrees Celsius heat, 90 atmosphere pressure. Sci-fi Venus paradise turned hellish in 1978. It flipped. Pioneer entered Venus, measured deuterium to hydrogen ratio. Deuterium is hydrogen. Oceans, 1 deuterium per 6,000 hydrogens. Venus atmosphere, 100. Scientists knew Venus bled. Light hydrogen fled. Heavy hydrogen stayed still, proving it. Studies estimate Venus once had water covering the globe tens of meters deep. No puddle. An ocean. Ocean's gone? Venus is flaw. Venus is close. 108 million kilometers from the Sun. Earth, 150 million. Sunlight falls with distance squared. Venus gets almost twice Earth's light total. Early sun dim. Venus coped. Oceans stayed calm eons. Maybe birthed life. The sun's core keeps fusing. Ash builds up, shrinks. Heat speeds fusion. Sun brightens. Every billion years, plus 7 to 10%. Venus eventually breaks. Next, in one word, runaway greenhouse effect. Sounds familiar. Earth debates greenhouse effect daily, but Venus had runaway. Different kind. The greenhouse effect. CO2 and water vapor let sunlight in, but block infrared from the ground. Like a blanket holding heat, keeping temperature steady. Without greenhouse warming, Earth averages minus 18 degrees Celsius. Oceans freeze. Moderate. Venus overheated. Sun warmed oceans, boosting evaporation. Vapor entered air. Water vapor's greenhouse effect beats CO2. More water vapor strengthens greenhouse warming. Temperatures rise, speeding evaporation. Adding vapor, a positive feedback loop. Once started, like a downhill snowball, unstoppable. Venus's oceans slowly boiled, evaporated, became atmosphere. First question answered. Oceans stayed, shifted from Earth to sky. But it wasn't over. High-altitude vapor met solar UV, which can split water molecules. Photolysis. 1 water splits into 2 hydrogen, oxygen. Oxygen is heavy, binds sulfur, forming sulfur dioxide. In Venus's atmosphere, hydrogen atoms suffer most by far. It's universe's lightest element. Mass 1. Lighter. Venus's upper air gets hot. Hydrogen can exceed escape speed there. Exceed it. Escape Venus's gravity. Drift into space. Thermal. Beyond thermal escape. Violent impact to escape exists. Solar wind. High energy particles from the sun. Protons. Particles strike upper atmosphere hydrogen like billiards, blasting atoms straight away. No global magnetic shield. Solar wind hits hard. Both mechanisms combine. Venus's hydrogen escaped to space, atom by atom, over eons gone. Water is hydrogen and oxygen. No hydrogen, no water. Hydrogen escaped. Venus's water was permanently dismantled, gone. Third question. Earth has oceans. UV. Solar wind. Why hydrogen remains? Earth has two defenses, Venus none. First, cold. Earth's atmosphere is unique. 10 to 15 kilometers lies a frigid layer. Temps hit -60 to 70 degrees Celsius. That's the tropopause. Vapor rises, freezes to ice crystal. Hardly any vapor gets past cold trap. Earth's water stays below the troposphere. Molecules miss UV, so no photolysis. Venus cold trap? It's so hot. The atmosphere bakes. Water vapor rises freely, then UV tears it apart. Second defense. Earth's magnetic field. Liquid iron nickel core flows, driving currents that generate it. It reaches space, the magnetosphere shield. Solar winds charged particles deflect around Earth. Most miss atmosphere. Venus lacks this. It spins so slowly its day exceeds its year. Slow spin and core weaken magnetism. Cause unknown. Scientists study. Result. Venus lacks magnetism. Solar wind strips hydrogen from its atmosphere. Earth has two safeguards, Venus none. So Earth's oceans endured 4+ billion years. Venus's disappeared in 0.3 to 1. What can Earth's defenses really hold forever? Cold trap needs precise atmospheric balance. Continued warming lifts troposphere. Shifting tropopause temperature and altitude high. Studies show warming weakens the cold trap, letting vapor enter the stratosphere, speeding photolysis and hydrogen escape. Possible risk ahead. Earth's magnetic field is normal, yet fluctuates and periodically reverses. Reversal greatly weakens field. Lasts millennia. Meanwhile, solar wind erosion will intensify. No short-term disaster, but long-term. Main threat is the sun itself. Still brightening. Cannot change. Models predict in 0.3 to 1 billion years. Stronger sunlight triggers runaway greenhouse. Oceans boil off. Hydrogen escapes. Earth's window closes. Hundreds of millions of years is distant. Humanity may not last. Venus shows habitability is fragile. Climate thresholds, once crossed, change is irreversible. Venus once had seas and air, life ready, yet slid into ruin. An orange-red hell. Next time you see Venus, the brightest dawn or dusk star, remember, it's not a dot. Once possibly habitable, showing billion. 3 props. CO2. Greenhouse effect. Ocean We have 2 defenses Venus lacks. Time to understand and respond. Time